Here is example 3. This time we're going to have to use the chain rule once or twice, and we'll also have to do a little bit of factorizing and simplifying to get to our final answer. Now let's set up the problem. And let's differentiate the individual terms. Now, differentiating e to the 4x should result in this here, 4e to the 4x, so multiplying by the differential. And differentiating this sort of binomial-esque expansion here, 2x plus 3 to the 6, bring the power down, take one off the power and multiply by the derivative. So I'm going to have 6 and then times 2 at the front, which is going to work out as 12. All right, now, once again, the quotient rule says that if I'm differentiating, this fraction, this is what I should get. Let's just get that very quickly. So in this case, we are going to have, making lots of space for my fraction ready, v, which is 2x plus 3 to the 6, times du minus u dv and the bottom is going to be a 2x plus 3 to the power of 6 squared. Okay, so this is perfectly fine at the moment. It does look a little bit messy though, so hopefully we can simplify that a bit more. What I'm going to do initially is I'm just going to bring these constant terms to the front and maybe get rid of some of these extra brackets that I have. I've also got a power of 6 squared, and using the rules of powers, I can multiply those together, so I should get a power of 12 on the bottom. Let's do that initially. So this is going to be initially equal to 4 e to the 4x. I'll put the e's next in front of these brackets too. Okay, and already this looks a little bit better. What I can also do is I can factorize the top of the fraction here. So there'll be some common factors. What you might also notice is there's a 2x plus 3 in every single term with various powers. So I'll be able to divide by a common factor there too. First of all, let's get rid of e to the 4x. Let's take that out as a common factor. So I'm going to have e to the 4x on the outside here. I'm going to keep the denominator exactly the same for now. There we go. I can also take out a common factor of 2x plus 3 to the power of 5 on the top. So I can take the full power out there. I won't be able to take the full power out here, but that's okay. So let's write that down. So that is e to the 4x, 2x plus 3 to the 5. And this is what I'm going to have left. All right, great. So there is a little bit more simplifying I can do within the brackets, within these square brackets here. I could even take out a common factor of 4 because 4 goes into 12. what I'm thinking of doing first is just sorting out these powers here. So what I'm going to do now is I'm going to deal with these parts. I'm just going to get rid of a factor of 2x plus 3 to the power of 5 on top and bottom. Rules of powers say I should take away to simplify that. So let's get rid of this completely. And this power is going to change to a 7. So let's just write that down again for good measure. So we'll have e to the 4x, 4 lots of 2x plus 3, take away 12, and the denominator is going to be 2x plus 3 to the 7. And I guess from here, I'll just tidy up what's within the square brackets here. And if I can factorize it some more, happy days. So I'm going to have 8x plus 12 minus 12. Oh, okay, cool. So obviously the plus 12 and the minus 12 are going to cancel out. And there is my final answer. I can write the 8x in front as well, or instead of. And there's my derivative there. Wonderful.